Alright, so let's go ahead and get started. Alright, in the previous unit, we investigated heavily how to locate relative extrema of the graph, so like mins and maxes, of a function by using the derivative. In pre-calculus, we talked about the difference between relative and absolute extrema. In the space below, distinguish between the two. Alright, so between absolute and relative, can you kind of think of an example, a definition, the meaning of between the two? What do they mean? How can you find them? Where are they located? Anybody give me some general ideas, then we'll create a definition here. Talking about relative versus absolute extrema.
Absolute applies to the whole graph.
Okay.
And the relative extrema is just like the areas of
It could be. It could be. Not completely right, not completely wrong. Any other ideas? Good guess, thank you. So if I gave you some kind of graph, could you tell me any relative extrema of the graph or absolute?
You could find two relative minimums.
Two relative minimums, okay.
One relative maximum.
So there's two relative mins. There would be a relative max. Okay, very good. Is there any absolute extrema, an absolute max or an absolute min?
There's an absolute min, but no absolute max.
Okay, in terms of this, because I have this continuing on, there's no absolute max that we know of, but there is an absolute min, the lowest point. If I have a function, though, that just ends at a certain point, if I told you the cutoff was right here, well, let's see, was right there, and this one maybe continues back down this way, there would be an absolute max right there. It's not a relative max because a relative changes sign, goes from positive to negative. Well, there's no negative here, but it is at the highest point, so it would be an absolute. And we're going to go through that definition a little more, and we'll understand that as we go through multiple examples down below. But we're going to say relative extrema are points on the graph of a function where the function changes from increasing, I'm just going to put an arrow, to decreasing, or vice versa. So either increasing to decreasing or decreasing to increasing. That's where you're going to get relative extrema. So like we found relative maxes and mins in the previous chapter. Absolute extrema are the highest and lowest points on the graph. Any questions? All right, so moving forward, pictured below are the graphs of f and g. Answer the questions about these two functions. So let's look at f first. First question says, identify the coordinates of the relative extrema of f. So who can give me some values of the relative extrema? Dan.
2, negative 6.
2, negative 6, and that is a what?
Min. Wait, extreme. Relative.
Well,
Okay,
we're asking-
I was thinking of absolute.
We're asking about relative right now.
All right.
So is that a relative min?
Well, yes.
Yes,
Relative.
okay. Are there any other relative mins?
Yes.
Where at?
Negative 3, 0.
Okay, so those are relative mins. Very good. Those 2 points, which would be this point here and this point here, are considered relative mins, which is what we found in the last chapter. We took the derivative and found our sign changes, so we know how to find those. Any relative maxes? Any relative maxes? Braden?
-1, 3.
-1, 3. Relative max. Very good. So that's that point right there. That's a relative max. All right, so let's go on to the next question. Still stay with f, so down below. On the domain of f, what are the coordinates of the absolute extrema of f? So is there an absolute min? Is there an absolute max? That's what they're asking about. Is there an absolute min or an absolute max? One, both? Braden?
Absolute min at 2, -6.
2, -6 is an absolute min. What about an absolute max? We can't find one. There's none on the picture, and in the domain there is not. So no absolute max. We're going to skip this bottom question until we go over the graph of G. So now let's go back up to G. Identify the coordinates of the relative extrema of G. So think about relative mins and maxes. Are there any? Are there more than one? And what are they? Did we find any? Dan?
-6, 2 is also an absolute min. Oh,
Where-
-2, -6. My bad.
Hold on, where are
2,
you?
-6.
We're on the graph of G now. We've answered this one
Oh,
and this one. We're over on the graph of
Yes.
G.
I was working left to right. My bad.
So we're looking at G for the relative extrema.
Yes. -3, -4, and 3, 2 are both relative mins.
-3, -4, and 3, 2 are relative mins. Very good. Any relative maxes?
-1, 4.
-1, 4. Relative max. Very good. On the domain of G, so what they have pictured above, what are the coordinates of the absolute extrema of G? So an absolute min or an absolute max? Do we have one? Do we have both? What are they? Go ahead. -3, -4 is a what? Absolute min. Okay. What about an absolute max? Yeah, 6, 5. So 6, 5 is an absolute max. Why is that not a relative max? It's an absolute, but why is it not a relative, Dan?
Because in order for something to be a relative extrema, it has to go from increasing, decreasing, decreasing, increasing.
Exactly, and we only see an increasing, there's no decreasing part. But it is the highest point on the graph, so it is our absolute max. Very good. So let's look down at the bottom question now. On the domain of the given information, did the absolute extrema occur at the function's relative extrema? Did the absolute extrema occur at the function's relative extrema? Look at both examples. Dan?
Yes and no.
Okay. Can you explain?
Some of them did, such as for the absolute minimum of f of x, it did occur on a relative, and the absolute minimum of -3, -4 for g did occur on a relative. But the absolute max, so 6.5 did not, and no absolute maxes and a relative max for.
All right. Very good. So what we're going to say about that, the absolute extrema could occur at a relative extrema. It could occur at a relative extrema, but it does not have to. And then I have one more side note for you to write before you flip. Side note. So, if this is true, the absolute extrema could occur at a relative extrema, but it does not have to. So, what can we say about this? We already talked about it, but this absolute max here, we can't have a relative there because why again?
Doesn't change sign.
Doesn't change sign, so that's an endpoint. It's ending there, there's nothing continuing. So only absolute extrema can happen at endpoints. Only absolute extrema can happen at endpoints. So was I right in saying so far, not too bad? Pretty easy material so far? Alright, let's go ahead and flip over then. Okay. So we have two graphs again. We're going to focus on F. On the interval, so we have to pay attention this time. They're giving us intervals. On the interval, -2 to 3. So on this interval right there. So we're talking about between those 2 points. On the interval, -2 to 3, what are the absolute extrema of F? So we're looking for absolute extrema. Is there an absolute min and absolute max? An absolute min and an absolute max. Braden, you have one?
It's absolute max at -1, 3.
Absolute max at -1, 3.
And an absolute min at 2, -6.
2, -6. Very good. Those are the absolute min and max. The highest point and the lowest point. Okay? Let's go to the next question, straight down. On the interval, -4 to 1. So our interval is changing this time. We're going from here to here. What are the absolute extrema? So an absolute max, and we need an absolute min. Go ahead and find those two. An absolute min and an absolute max on that interval. So if you want to shade it with your pencil, shade the area so you know where you're looking, and then you can erase it when it asks you for a different interval. Okay, did we find either the absolute max or min? Anybody find them? Stevie, were you able to find one of them at least?
With a min of 1, -3.
1, -3, very good. Anybody else have the max? Colton, you want to say the max?
Is it -4, 4?
It is -4, 4. Thanks for urging them, Stevie. All right, negative 4 comma 4 is your absolute max. Very good. All right, let's go back up to G before we go down any further. So up to the graph of G. On the interval negative 4 to 5, what are the absolute extrema? So we're looking from negative 4 to 5. We want to know what the absolute extrema are in there. So we're looking for an absolute max and an absolute min. Anybody have an answer? Go ahead.
Have an absolute min at negative 3, negative 4.
Negative 3, negative 4.
Max at 5, 4.
5, 4. But what else do we see? Go ahead, Dan.
The 4's also reached that negative 1.
Yeah, on this interval, we can see there's two values where that's reached. There's a max there and a max there. They're at the same. So we're actually going to list both of them. Negative 1, comma 4 and 5, comma 4. They're both the absolute max. They're both at the highest point. Very good. Okay, let's look at the second interval. On the interval from negative 2 to 6, what are the absolute extrema? So absolute max, absolute min. Find your absolute extrema.
Max at 6, 5.
Very good.
Min at negative 2, 0.
Exactly. All right, so let's, after doing both of these problems, looking at two different intervals for both of them, let's try to answer the question below. When the domain is restricted, so that means applying the different intervals. It was restricted here and here and here and here. They restricted it two different ways for each problem. So when the domain is restricted to a particular closed interval, at what three places that the absolute extrema could exist? So what are three places when you restrict that domain? So if you want to go up and draw lines on one of them again and think about it, there are three places where you could find absolute extrema. So where are they? Absolute extrema could exist. We're going to list three different places. So look at your two examples above. Think about the intervals. Yeah. Endpoints, that's the first one. Very good. So endpoints. Endpoints on interval. Very good. Think about some of the ideas you know from the last unit to maybe help you answer this question. Or absolute extrema, where could they occur? We know they could occur at endpoints. Very good.
Relative minimums.
Yes. How do you know that it's a relative min? How would you find that according to the last chapter, last unit? You're on the right track.
It is increasing and decreasing like that.
Okay, you're getting really close. You're like jumping right around the answer. You're so close. So he says where it goes from increasing to decreasing or decreasing to increasing. But what's that actually mean? How do we find that? What did we use last unit to help us find where that was happening?
The slope is 0.
Yes, where the derivative is 0, so that's where it's switching. So Dan, you were all around it, but yes, that's correct. So where f prime of x is equal to 0. Good job putting your ideas together, guys. And you want to think along those same lines about what we just did for number 2, but a different outcome for number 3. So kind of along the same lines as number 2. Where f prime of x is what? Yeah, that would be the same as 2. Undefined, very good. Because where it's 0 or undefined, there could be possible extrema. So very good. Those are critical points. So those are the 3 places that absolute extrema could exist. So when you're looking at your function, those are the 3 places you should look for absolute extrema. All right. Now, if we go down, this is the actual extreme value theorem, so EVT. So we're going to actually write the extreme value theorem out here. If f of x is continuous, if it's continuous on a closed interval, that's going to be important too. Continuous and closed interval, those are important. The interval would be a comma b. Then f of x is guaranteed to have at least one absolute min and one absolute max on the closed interval. So again, if f of x is continuous, so no holes, no jumps, on a closed interval, so they give you the values just like they did up above, then f of x is guaranteed to have at least one absolute min and one absolute max. Up above, were we able to find at least one for each of those? For each of these problems, were we at least able to find one absolute max and min for each? Yes. And in some cases, we were able to find 2, but there's at least 1. So that's what the extreme value theorem is telling you. That if you're on some closed interval and you know it's continuous, there's at least one absolute max and one absolute min. Anybody still copying here? Good. All right. Let's see. Page 265. Okay. So on to page 265. Consider the cubic function, and it is listed there, to answer the following questions. Determine the intervals where f is increasing and decreasing. Justify your answers. So again, think back to last unit. That's what we're going to do here. How would we figure out where it's increasing and decreasing? What do we need to do? From last unit, how would you find where it's increasing and decreasing? We know how to do this. Okay, we need to find the derivative. F prime of x. If we take the derivative, negative 3x squared minus 12x minus 9. What do we need to try to do with this derivative, though? Find the critical points. So I can factor out a negative 3. Gives me x squared minus 4x, well, plus 4x, plus 3. So I factored that out. Now I want to see critical points. You set it equal to 0, and you try to factor. If you can't factor, we use quadratic formula, but let's try to factor it. So we have the negative 3 there, and we want to try to factor the x squared plus 4x plus 3. Does it factor? Are we lucky in this problem? Yeah, we are. We get x plus what and x plus what? Thank you. X plus 3, x plus 1. Very good. Critical points you solve when it's equal to 0. So we get x equals negative 3 and negative 1. Those are the critical points. Again, just like we did before, nothing new yet, create your table. Negative infinity to negative 3, negative 3 to negative 1, negative 1 to infinity. So we're not doing anything new at this point, really. We want to know when f prime of x is positive and negative. So, the derivative in this interval, is it positive or negative? So take some time. If you need to use your calculator, or just plug in a value in your head and figure it out. We don't need the actual number value. We just need whether it would be positive or negative. So in this interval, is the derivative positive or is the derivative negative? Anybody else a little warm? Want to crack a window for a little bit? All right. If we get too cold back here, you can go some shut it. All right, so did anybody determine when it's positive, when it's negative? Anybody determine? Well, and somebody help me out. All right, Dan?
It's decreasing on negative infinity, comma negative 3, and negative 1, comma infinity as f prime of x is less than 0.
Okay.
And it is increasing at negative 3, comma negative 1 as f prime of x is greater than 0.
Okay, so in words of the table, the derivative is negative here, so the original is decreasing. The derivative is positive here, so the original is increasing. And the derivative is negative here, so the original is decreasing. So what is happening at these 2 points here, our critical points? We have a what and a what? A min and a max. Min and a max. Now, your official statement for this question, especially if this is an open-ended, I don't have a lot of room to write it out, but what you would need to state, especially if it's an open-ended, f of x increases on, and write your 2 intervals, because f prime of x is positive. And then your second statement would be f of x decreases on, write the intervals, because f prime of x is negative. So we've done a lot of that. You had some open-endeds like that in the last chapter on the test. But just be sure that you state that if you have a problem like this. So if you have room, go ahead and write that down. But if f of x is increasing, it's because the derivative's positive. If it's decreasing, it's because the derivative is negative. All right, let's look at letter B. Determine the coordinates of the relative extrema of f. Justify your answers. So relative min, relative max, we want to find them. What would they be? Again, the answer may be right in front of you. We may have already talked about it. We just need to know what it is and explain how you know that's it. So let's talk about a minimum first. Relative min. Is there one? How do you know? If there is, where is it? Use the information from up above to help you. Braden?
F of x has a relative min at x equals -3 because f prime of x changes negative to positive.
Exactly. Relative min at x equals -3 because f prime of x changes negative to positive. And if you wanted to state your actual coordinate is -3, 2. Okay. Let's talk about relative max. Is there one? If there is, where is it? How did you know?
It has a max at x equals -1 because f prime of x changes positive to negative.
Very good. Relative max at x equals -1 because f prime of x changes from positive to negative, and your point would be -1, 6. Very good. Do we have any questions on that? Basically, you're using what you learned in the last unit. We found the table, and that's just what they're talking about there. They're the relative mins and maxes. It's where it's changing from positive to negative or negative to positive. So all that information we already know how to do. All right. So if we move on here, what I would like to do for these last ones here. They tell you pictured below is the graph of a function f on the closed interval from -4 to 1. They give you that. Over here they're asking about the interval. And they want you to identify different things on this interval. So I would like you to go ahead and try to answer those questions on the right there, and then we will go over the answers together. So go ahead and try to answer those. After you get answers for each of them, we'll check our answers. There's at least a hint for some answers. All right, I see most of you are finished, few still working. But let's go ahead and review the last few answers then. So on the interval from -4 to -1, any absolute maximums? Braden.
-4, 6 and -1, 6.
-4, 6 and -1, 6. Very good. Those are both maximums on that interval. They're at the same spot. So they're both absolute maximums. Very good. Absolute minimum on the same interval. Does anybody have? Stevie?
-3, 2.
-3, 2. Very good. Now we're going to change the interval. It goes from -4, so from over here still, until 1. Absolute maximum. Stevie?
-4, 6, -1, 6.
Yep, didn't change. Both maximums are still the same on the graph, even though we expanded. Absolute min.
1, -14.
Yes, 1, -14. Thank you. So how do we feel about absolute extrema? Pretty good? All right, so tomorrow we're going to probably finish up this section, the first section here with absolute extrema, but we're going to do that tomorrow. So you have a couple minutes. If you want to look at a few homework problems, you probably have enough time to do 1 or 2.
I think it's that open space.